So continuing from what we did yesterday with the reciprocals, I want to actually go over division now. So I've set up that table for you again to help you out with some signs for the answers. Here we go. So we have sum number A, my cursor here, sum number A divided by sum number B, and you'll get some quotient. Okay, so just like all the other tables, if the first number is positive, second number is positive, the quotient is going to be positive. First number is positive, second number is negative, quotient's going to be negative. So remember, quotient is just the answer for, that's our answer for division. Okay, if we have first number negative, second number positive, our answer is going to be negative. And then last we have a negative divided by a negative is positive. So I didn't mess this one up this time. So that's how our signs are going to look like. And remember that when you divide, you'll need to multiply by the reciprocal. And so a few years ago, a student of mine taught me this. And that looks like this. Keep the first thing, change the sign to multiply, and then flip to the reciprocal. Okay, and so an example of that could look like this. If I had 15 divided by negative 3 over 2. So I'm going to keep the 15, change the division sign to multiply, and then flip the negative 3 over 2. Okay. And then it's just like what we did before. So if I want to multiply, here we take this and turn this 15 into 15 over 1 times negative 2 over 3, and so just multiply straight across. 15 times negative 2 is negative 30. 1 times 3 is 3. Check if you can reduce this. You can reduce it, right? It goes into 10 times, and then I gotta preserve this negative. So final answer for this guy is negative 10. Okay, and so this brings up a good point here, because you don't always have to keep, change, flip, because what if I asked you to divide something that looked like this? There's nothing to keep, change, flip there, but you know this is division, right? Because of that line. So this would be a case where this is not keep, change, flip. You would just be able to divide this because you know 6 goes into 2 3 times, and then you still have that x left over, and so that's what we have left, right? Okay, so there's some rules for division here, which some of them I've already told you already. So remember, you can never divide by 0. It doesn't matter what number it is or what, it doesn't matter. You can just never divide by 0. So this is never possible. Oops. That's never possible. This is never possible. If you have, that's not possible. Okay, so anything divided by 0 is never ever possible. Another thing to remember is that order matters, right? Remember when we did this order of operation stuff? I told you have to work from left to right here. So, let's say we had this. 8 divided by 2. We know that 8 divided by 2 is 4, right? But is this the same? 2 divided by 8? Is that the same as that? So here's A, here's B. So let's see. So 2 divided by 8 would mean I have to do 2. This is really 8 over 1. So if I flip it over, it's going to look like that. Okay? Make this 2 over 1. 2 times 1 is 2 over 8. I can reduce these guys, right? They both go into 2. Okay, is 4 and 1 over 4 the same? Nope, not really. So order does matter. One more thing I want to show you here is if I had something that looked like this. This is one that shows you that order of operations has to happen. 12 divided by 3 is 4. 4 divided by 2 is 2. Okay. As opposed to 12 divided by 3 divided by 2. So this is going to show you the order of operations really does change everything up. So I have 12 divided by 3 divided by 2 is going to end up giving us what? We are not really sure right now, right? So let's change it to look like this maybe. 3 over 2 like that, okay? Then we know this is going to turn into keep, change, flip. And what happens here? Let's put this 12 over 1 so that it can be a fraction, and we multiply straight across. So 12 times 2, 24. 1 times 3 is 3. And is this going to reduce? 24 divided by 3 reduces to 8, right? So 2 and 8 are totally different numbers. So the order of things matters. The order of operation matters. You gotta do them. Because it's, again, like as we start to get into more complicated stuff, my friends, it's going to get more difficult to keep up and understand that business, okay? So let's go ahead and try some examples here and see how you do. So let me get into a blank area here and try. Okay, so let's say I gave you for our first example, let's say negative 12 divided by negative 5 over 6. Okay, so remember this is going to be one I'm going to have to keep, change, flip because it's not just one fraction, right? So keep the negative 12, change to multiplication, and then flip. And then what do we have to do again to this negative 12? We're going to put it over 1. Okay. So negative 12 times negative 6 is going to give us 72. 1 times 5 is going to give us 5. And there's really nothing we can do with that anymore. We can't reduce. Okay, so that's all we can do with that. Let's look at a second one. Let's go 48a divided by negative 8. Okay, so am I going to have to keep, change, flip here? Do I have two separate fractions or two separate numbers? No, okay, it's just one fraction. So let's look at the numbers first. Don't worry about the a. Can 8 go into 48 at all? It can, right? It can go in 6 times. I have a negative here, so I gotta preserve it. And then I bring my a here. Okay, and we know that it's gonna end up being 6a and not 1 over 6, because which is bigger, the 48's on the top or is the 48 on the bottom? It's on the top, okay? So if it was on the bottom, then we're gonna have to put the whatever the bigger number is, that's where this number is going to end up with. Since the bigger number's on the top, it stays here like this. But if it was 48 on the bottom, we would have made it 1 over 6a. Okay, so since the bigger number's on top, it just stays like this. Okay, so let me show you what I'm talking about here. So if it ended up looking like this, see how the 48 is on the bottom right here? So that means when we cancel here, the 6 is going to end up going here on the bottom. And the a is on the bottom, so it stays there. And when we cancel and nothing's left, it's not 0, it's 1. Okay, so that's the difference that we have here. Because if we had this guy, remember, when there's no denominator, we just assume it's 1. Let's try another example. So if I have negative 6 times x over 6. Do I have to keep, change, flip in this problem? This is a tricky question. Keep, change, flip in number 3. Answer is no, okay? We do not keep, change, flip. Why? Because are we dividing in this problem? Am I asking you to divide right here where my little circle is? I'm asking you to multiply, so we already know how to multiply. Remember, we did this a few days ago. No keep, change, flip necessary. What do I want to do with this negative 6? Let's turn it into negative 6 over 1. And we go negative 6 times x becomes negative 6x. 1 times 6 is 6. These two guys can cancel out, right? And since there's nothing left, they become 1. So it becomes negative 1x over 1. And remember, the 1's aren't necessary, so you can just leave it as negative x. Here we go. I got one last one for us today. It's an evaluate problem. Remember, I told you evaluate is just a fancy word for substitute. So basically it's telling me that wherever I see an A, I want you to plug in negative 3. Wherever you see a B, plug in negative 1. C, plug in a 2. And a D, plug in 6. Okay, so if I gave you an equation that looked like this, A times B times D all over A plus C, all I'm doing is plugging in. So here we go. So wherever I see an A right here, plug in negative 3, and I'm going to times that 2. I have a B right here, and there it is, negative 1. I have a D right here, so I'll go to my key here. D is 6. Looking at the denominator, I see an A there. A is negative 3. Here's my C. I'm going to plug in a 2 there. And so here we go. So let's simplify. On the top, negative 3 times negative 1 is positive 3. So these two guys are going to give me a positive 3. 3 times 6 is 18. On the bottom here, negative 3 plus 2. So if you're still having trouble with that, here's my number line. Here's 0, 1, 2, 3. So I'm starting at negative 1, I'm starting at negative 3, and I want to go plus 2. So plus 2 is going to go to the right 1, 2, and I end up right here, which is negative 1. And can I reduce this? 18 divided by negative 1? I can. It's turned into negative 18. And that's it.